Hello everyone. This video is to help you to calculate the change in pH of a buffer solution when a strong acid is added. Here the strong acid added is HCl, hydrochloric acid, and which is added with 0.02 moles. But we are going to deal with these numbers later. First we need to find out the pH of the buffer before we add the HCl. To get that, we need to have the acid concentration and the salt concentration and the Ka of the weak acid. So these three numbers are given. So let me start with before adding HCl. I need to find the pH of buffer. How would I find? I can find out first H plus ion concentration using this equation. I need to remember this equation. I can substitute the values which are given in the question. 6.3 into 10 to the power negative 5 multiplied by concentration of acid is 0.350, concentration of the salt is 0.650. So I will get 3.39 into 10 to the power negative 5 moles per decimeter cube. So pH is equal to negative logarithm of H plus ion concentration. So I substitute this H plus ion concentration, which is equal to negative log of 3.39 into 10 to the power negative 5. When I do so, I am getting 4.47 as the pH before the addition of HCl. Now to get the change, I am going to find out after adding HCl. I am going to find the pH of buffer after adding HCl. So again, I cannot use the same concentration because when I add acid, it is going to shift the equilibrium to the left. So there will be more weak acids will be formed and there will be a decrease in the concentration of salt. So what should I do? Always a new concentration of the acid is going to be the old one, that is before adding 0.350, and the strong acid added, the amount of strong acid added, which is 0.02. So you get 0.37. You get 0.37. That is the concentration of acid, moles per decimeter cube. And for the salt, it will be decreased by the same amount. So 0.650 minus 0.02. So it will be 0.630 moles per decimeter cube. Now I use this to calculate the new concentration of H plus, which is Ka multiplied by concentration of acid over concentration of salt. So Ka is the same, 6.3 into 10 to the power negative 5 multiplied by 0.37 divided by 0.63. So I'll get the new H plus ion concentration, which is 6.3 exponent negative 5 multiplied by 0.37, 0.63, which is equal to, I am getting 3.7 into 10 to the power negative 5. 3.7 into 10 to the power negative 5 moles per decimeter cube. So the pH is equal to negative logarithm of H plus ion concentration, which is equal to negative log of 3.7 into 10 to the power negative 5. So which is equal to negative logarithm of this answer is equal to 4.43. This is the pH after adding the acid. So now they are asked to find out the change in pH. So change in pH is equal to before minus after. So I get 0.04. This is the change in the pH. So what will I do? I will first find out the pH of the buffer before the addition of the acid. I'll get some number. Then after that, when I add the acid concentration is going to get increased. So you will add the concentrated acid concentration to the weak acid concentration. That's what we have done here. 0.35 plus 0.02. 0.35 is the concentration of the benzoic acid. 0.02 is the concentration of the hydrochloric acid added. And equally you will have to subtract this from the salt, because that will combine with this H plus to give the weak acid. So the 0.650 is subtracted with 0.02, so you get 0.63. Then the regular procedure to calculate H plus and pH with the negative logarithm of H plus ion. So you will get the pH after the addition of HCl. So then take the difference, you will get the pH change in the pH. You can use the other equation for the pH of buffer. That is also okay, but I used here two-step equation, that is finding H plus and then pH. You can even use the direct equation, which is pH is equal to pKa plus log concentration of salt over concentration of acid. So you can use this equation also to get the pH directly when you know the concentration of acid and concentration of salt. I hope this video helps you to understand how to calculate the change in the pH when a strong acid is added to a buffer. Thank you for watching.